So when I saw ChatGPT for the first time, I was so blown away. I never in my lifetime expected to see that kind of advancement. What was your ChatGPT moment?
I was impressed, but honestly, I was not super surprised, and let me tell you why. The first question I asked it was, who's the current king of Portugal? Because I'm from Portugal, and Portugal does not have a current king. And it gave me a whole essay about the current king of Portugal. So we kind of started off on the wrong footing. But having said that, it is very impressive. There's no doubt that there's a major leap of progress here. But the thing that I think that is people realize less often, but is equally important, is that if you actually extrapolate what you could do with language models, starting from the 50s, as you get more data, this is exactly where you'd expect them to be. Now, the amazing thing about transformers is that they basically let you condition on a much larger number of previous words or whatever, tokens, right? By being smart about which ones you pay attention to. Right, so there's the data, there's the compute, and there's the transformer algorithm. But to a first approximation, to someone who's not technical, you can still understand these large language models as being language models. And the thing is, I mean, I don't know if you had this experience, but even with a banal Markov chain model that conditions on 2 or 3 words, as you condition on 2, then 3, then 4 words, it gets much better very quickly. Right? It's already surprising that with like a 3 gram, it's generating kind of plausible text. And the big revelation of Google when they did spelling correction, machine translation, like if you can go to 4 or 5 grams, which they could with the web, things get amazingly better. So if you actually extrapolate that curve, we are where you'd expect us to be.
So you're not so surprised. What about you, Trey?
I think in the research community, at least, my experience was the bombshell was GPT-3, which came out about 2 years earlier. And that was when the first time they showed they scale up 100 times, and it was like way better at multitask learning. And it took about 2 years for them to have a product that actually blew people's mind, right? And so that sort of suggests that the technology was already there. What it needed was a killer application, right? In some sense, it means that it suggests that we're probably not even using the models we have right now as well as we could. And so I think the most surprising aspect to me was like how long it took them, like 2 years to go from GPT-3 to ChatGPT to have this sort of amazing product that is now the majority of their revenue.
So you were not so surprised either?
I think I was surprised at how long it took them to get there.
He was anti-surprised.
So you were not surprised?
Underwhelmed.
What about Jakob?
So I wasn't surprised by the capabilities of ChatGPT. And that was to a large extent for very similar reasons as why Tree wasn't. I guess now it's been publicized, in a bunch of places that Noam Shazir, for example, was running pretty large transformers even already in 2018, 2019, that yes, they weren't tuned towards conversational use cases in any which way, but what they were already able to do and how coherent the text already was that they produced really, just meant the writing was on the wall. The big surprise with ChatGPT was actually, in my opinion, for me, completely different. The big surprise around ChatGPT was how quickly this model that wasn't that much better than what we expected to actually see, and maybe even came a bit later than one would have thought, how quickly users, and not just 1 or 2, but 100 million users, were able to, in incredibly creative ways, use this tool that, again, wasn't that mind-blowingly better for all sorts of use cases in very valuable ways. And how quickly that happened, to me, was absolutely mind-blowing.
Let's move over to scaling. So I did a little research. I used ChatGPT and Perplexity. I hope my numbers are correct. But ChatGPT-2 costs around $50,000 to train. ChatGPT-3 costs around $3 million to train. ChatGPT-4 costs around $100 million to train. The next model, ChatGPT-5, will arguably be in the billions. ChatGPT-6 will maybe in the hundreds of billions. Noam yesterday indicated maybe would be up to the trillions. So when you hear a lot about scaling laws, that all we need is to scale with more compute, more data, and so on. Is this really feasible, right? And I guess, do you believe in the scaling law? Or do you believe that there are additional innovations that needs to take place for us to get to where we want? And if there are innovations, are those in hardware? Are they in architecture? Or are they in the way we use data? Jakob, do you want to start?
Yes. But no, we need all those things. Our current hardware is not ideally suited to what we want to do with it. Our architectures, I can say that from experience, are very much optimized for the hardware that we currently use. And we are certainly, and that I guess was also demonstrated clearly in a bunch of talks yesterday around, say, data efficiency of humans as they learn things, the way we use data certainly is also suboptimal. The more we can tie optimizing all of those things jointly, the better. And I understand it's very difficult, but now there are more than a few entities that at least have the opportunity to do so, and that's really where I believe some of the biggest kind of potential lies for step changes. I will say, hardware is maybe the one that's most due for a bigger shift in terms of thermodynamic efficiency.
Okay. Are you able to point to specific things that you expect within the different areas, hardware, architecture, and the way we use data?
I don't have a crystal ball. I think when it comes to hardware, really making use, exploiting the fact that we actually don't want discrete computation, but we really want continuous computation, is something that we should be able to exploit to gain at least an order or two of magnitude efficiency improvements.
But even that is pretty limited in the picture that we are talking about.
I mean, it would probably help to answer the question where ChatGPT-5 is.
True.
So step by step. I'm also saying at least,
yeah.
Right? And I don't know exactly how we're going to get there, but it definitely seems that we're wasting an enormous amount of efficiency on remaining discrete in a regime where we don't actually want our computations to be discrete, but we're perfectly happy with continuous computation. Yeah, go for it.
I'm glad you said that, because I think precisely the opposite. The whole reason we're wasting so much compute is that we're doing continuously something that we should be doing discretely. The way we're going to get more efficient is to get rid of all that ridiculous floating point arithmetic that you have to do for backprop. Your brain doesn't, I mean, like, come on, right? Clearly we're missing something here. And like, right, I can do the same in fewer bits, right? Do you
I think
agree
that's
with that?
very interesting. Jakob?
So I also, to a certain extent, agree with that. Right? And this is what I was trying to allude to earlier when I said we're not seeing the efficiency gains from types of reasoning that should actually be much more symbolic or much more discrete. Right? So at that level, I agree with you. However, the underlying substrate, there I don't think there's any evidence that any other, certainly not our brains, operate in a way that is discrete and...
No, on the contrary, I would say that I understand what you're saying, but I'm actually saying something different, which is at the lowest levels of both brains and the computers, there are very strong reasons to use discrete instead of continuous. And don't just take my word for it. Like talking with Bill Daly, who's the chief scientist of NVIDIA, he says, he's a very, very strong believer in this, and I think for good reasons.
Pedro,
Like, in the case of... Yeah, go ahead.
Do you believe in the bitnet that we launched now, so you can distill models down to 1 point, or ternaries, so down to 1, zeros, and -1?
No, yeah, so there's a whole line. For example, a colleague of mine at UW, Ali Farhadi, sold a company to Apple that what it did was maximally reduce the number of bits, often down to just 1 bit per weight.
Yeah.
XNOR, right? Like was XNOR networks, right? So
that's phenomenal, right? Because then that.
But it gets better than that. A student of mine many years ago actually did a paper on purely discrete version of backprop.
Okay.
Actually, the first project I ever did in grad school was trying to do a purely discrete version of backprop. And I didn't know how to do that then, but now we do. But maybe the more interesting one is not even the hardware, it's the neurons. Our neurons are fundamentally discrete for a very fundamental reason, which is that analog doesn't work.
Are they really discrete though?
I'm not sure we know that. I'm really not sure we
I
know
agree
that.
with Jakob on that. Try.
I think we found out that sort of continuous makes it easier to optimize, sort of to find the answer, because backprop or gradient descent works beautifully, right? Fundamentally, after you've trained the model, you can quantize to 2 bits, 1 bit, and a lot of times it will work. So we have existential proof that yes, we have intelligence if you only use maybe 1 bit per parameter. But the way to find that intelligence, to find that solution, the easiest is still to do floating point computation and run massive matrix multiplication.
I also disagree with that.
I would also argue, just in terms of experimental evidence for, say, some hypothetical discrete nature of our neurons, I don't think we're anywhere near a conclusion there. We keep finding new ways in which different neurotransmitters affect communication between neurons in ways that really don't look discrete, at least for all we know.
Okay, so one thing at a time, right? I think there's actually many interesting issues here. But here's the thing. What's wrong with current machine learning is backprop. The reason our data efficiency is so terrible compared to humans is backprop. Backprop is a local optimum in the space of learning algorithms. I mean, I use backprop as well. Backprop is wonderful in many ways, but we have to be able to jump out of the local optimum. I mean, AlphaGo beat Lyseggen because they spent like a large fraction of Google's computing capacity training that system, playing millions of games against itself. And Lyseggen learned it in, 10,000 games. We human beings are fundamentally better, faster at the problem with backprop is that it extracts very little information from data. And I mean, we have all this, continuous optimization equipment that we could bring to bear on machine learning, and I think that's been wonderful. I'm not saying that it doesn't work, but I'm saying a lot of precisely the barrier that we face in terms of it being so inefficient, so hard to get beyond, the problem is with backprop.
Where do you expect to see the most interesting and the most critical breakthroughs? Is it hardware, architecture, or data?
I think so far it's probably data, coupled with algorithms. I think the hardware, I don't think you can do a lot. I think fundamentally, matrix multiplication is sort of the right thing to do. Thinking from how much compute you need to do versus how much sort of memory you need to move around. I think matrix multiplication is pretty much optimal. So hardware will get faster, maybe 2x every year or so. But I think algorithms and data probably will have higher ceiling. We're clearly way more data inefficient than we should be. Like that part is clear.
And how do you think about data? Because you're starting to run out of data, right? So if you're going to be innovation on the data side, what are the innovations that you will see?
Yeah, I think one is getting data from different sources, like audio and video data, which so far we haven't seen as much transfer to sort of intelligence. The other one is, this is classical, which is active learning, which is how do you select the right data? Maybe the model's gotten really good at English. You should probably train more on French or code and whatnot. So far, it's been quite cumbersome to do so people haven't done that as much. But that's clearly how humans work, right? Once you've mastered grade school math, you move on to the next thing.